According to the question, the point P lies on a circle and it is the same distance from the y-axis as the point P. So if Q lies on a circle and it is the same distance from the y-axis as the point P, that means Q must be vertically above point P so that it can be the same distance from the y-axis, and since it's lying on a circle, point Q can be somewhere that is like here, which means that it is going to have a x-coordinate of -7. This here is the chord of a circle. So that means that if I were to draw a horizontal line from here, from the center of the circle, it is going to cut it at the midpoint of P and Q. That means from -1 all the way until the y-coordinate of the center of the circle is of 2. That means this distance here is going to be 3, and this distance here will also be 3. Which means that the y-coordinate of Q from observation is going to be 2 plus 3, so the y-coordinate is going to be equal to 5. And with this, I want to find the equation of the tangent that is going to pass through Q. So I'm going to find the equation of this here. And to do that, I'm going to first find the gradient of CQ, because this is going to be 90 degrees to here. With the gradient of this, I'll be able to deduce the gradient of the tangent. And with the coordinates of point Q, I will be able to come out with the equation of the tangent at Q. So let's find first the gradient of CQ. The gradient of CQ is going to be equal to 5 minus 2 divided by -7 minus 3. This is equal to -3/4. So now I can deduce the equation of the tangent at Q. And that will be y minus the y-coordinate at Q, which is 5, is equal to the gradient of the tangent, which is -1 over this. So the gradient is going to be equal to 4/3 of x minus the x-coordinates of Q, which is x minus -7, so x plus 7. If I were to multiply throughout by 3, it is going to be 3y minus 15 is equal to 4x plus 28. So 3y minus 4x minus 43 is equal to 0 is the equation of the tangent at Q.